In this demo, we will make sure that the selection of the concrete implementation of a service is handled outside of the class that needs it. We've registered a concrete type, local mail service. That will make it hard to work with a testing service in a different environment. Let's improve on this. Let's switch to our local mail service. What we're going to do is create an iMail service interface which contains this send method. We can do that by right-clicking the type name, choosing for quick actions and refactorings, and choosing to extract the interface. What we want to extract is the send method, and we want to save that to a new file name, let's say iMail service. That's also the name of the type we want our interface to be. Let's click OK. There we go. Local mail service already implements iMail service. So we've now got a contract and an implementation. The idea is that we're going to let the container provide us with different implementations of iMail service. So we're going to need another implementation. We've already got a local mail service. Let's add a cloud mail service. So we right-click the services folder and we choose to add a new class. We name it Cloud Mail Service. For starters, I'm simply going to copy over the implementation from our iMail service, and we're going to make one change. We're going to ensure that Cloud Mail Service is written out to the console window. Like that, we know which service is effectively used. We've got two different implementations now. Let's open the program class again. There's an overload we can use for add transient. Instead of only providing the concrete implementation, we can provide the interface, which is iMail service, followed by the implementation. We've now essentially told the container that whenever we inject an iMail service in our code, we want it to provide us with an instance of local mail service. So let's change the constructor injection in our points of interest controller, so we request an iMail service instead of the concrete implementation. So we switch out local mail service for iMail service. And that takes care of that. Let's give this a try. We send our request to delete a point of interest. It responds with a 204 no content. So far, so good. And if we look at the output window, we see that a mail was sent using the local mail service. So our result is exactly the same as before, as we've told our container to provide us with the concrete local mail service implementation. But how can we differentiate between that one and the cloud mail service? Back to the program class. One way of doing this is by using compiler directives. A compiler directive tells the compiler to omit or include pieces of code on compile, depending on the symbol used being defined. If we're running a debug build, the debug symbol is automatically defined. So we can write code that states that when we're in a debug build, we're going to add the local mail service on our container, and otherwise, we're going to add the cloud mail service. We're currently working in debug mode, so the registration for Cloud Mail Service is grayed out. Let's change the build to release. And now the registration for Local Mail Service is grayed out. So if we build and run this, an instance of Cloud Mail Service will be provided. And that makes sense. We've got a local mail service, probably to be used during development, and that Cloud Mail Service, well, that's probably something you want to use in an environment which requires a release build. Let's give that a try. Let's send our request. 204 no content, so far so good. And if we have a look at the console window, we see that this time the Cloud Mail Service was used. With that, we now know how to work with dependency injection. That means that we now know how to get rid of this static cities data store instance we've been using. A static instance is nothing more than a singleton. So let's comment out this current property here. Seeing the current property on the cities data store no longer exists, Visual Studio's error list nicely tells us where we have to change our code. Within our points of interest controller, which is where we have to change our code, let's inject the data store here. And just as with the other instances we've injected, let's store it in a private read-only field, and let's add a null check. There we go. We're injecting the cities data store here. If we want this to work, we obviously have to register it on our services container. We do that in the program class. For that, we call into builder.services.addSingleton this time. And we pass through cities data store as the type. For that, we add a using statement to cityinfo.api. All right, all that's left now is fixing the errors which showed up because the current property on the cities data store no longer exists. And that's quite easy to do. We simply replace citiesdatastore.current with _citiesdatastore. And we do that at all the different places in our code where we used citiesdatastore.current. There we go. Let's save this. And let's do the same for the cities controller. So we inject the data store, store it into a field, add a null check, and replace all references to citiesdatastore.current with _citiesdatastore. Alright, let's switch back to the debug build, and let's build and run this. Just to check whether all of this still works, let's get some cities. That still seems to work. And let's get some points of interest as well. And that also still works. And with that, we got rid of our static property. That's it for that small intermezzo. Back to the mail service. That address we sent that mail to, well, we don't want to hard code that. We want it to be in a configuration file. And it also makes sense to make this different depending on the environment we're in. If we're still working on code and testing it, we want this address to be different than when we're in staging or production. That's what we'll cover in the next two demos.